Okay, so let's now talk about the runs I did and what I changed and why. So we go to results. So workflows we've been working. Results is where we see what we've done, and I ran a bunch of uh, models. I also, like I said before, I created a spreadsheet that, maybe this isn't the most efficient way of doing it, but I just kept track of all of those four types, the four inputs, and the complete outputs here. So we can refer to that if we need to. But so I ran the first building. The first iteration I ran was a 1960s baseline building, which is just me sort of just making up what I thought would be the right. I mean, in an intelligent way, what would have been a system, envelope loads all the four categories that they would have built, in the 60s for a commercial building. Um, and I got a pretty high site EUI of 248. The baseline for a building. So what I used as my uh, building prototype was a medium-sized office. I did not do anything nuanced. I just called all of the zones office. I didn't say that there was. Oops, I didn't say that there were corridors and uh, bathrooms and meeting rooms and offices. So this is not accurate for anything real, but each model is comparing to something relevant. It's consistent throughout, internally consistent, so it's useful as just something to play with. I started with this. Um, Maybe I didn't need to go this large. Maybe shouldn't have done it as complicated. But one reason I did this is that I wanted to have a building that was large enough that, first of all, sort of fit the studio program to some degree, just because I wanted to see how that would work as I was developing this, and I wanted something that was large enough where daylighting would be manageable. If you have a really small building like a house, daylighting is just completely different because you typically bathe your interior with light pretty easily, and you want that often to try to get solar gains, but then you've got real problems with, and it's just not what we're talking about in terms of the studio. We're talking about a larger building, and so I wanted to be experimenting with that. Anyway, so my 1960s building. Let's see what the results were. Pretty high site EUI based on the baseline medium office. We can talk about in more detail some of these. Uh, you know, well, actually, let's go look at the. Um, I'm going to look. I'm going to go to my templates and look at my. I created a template here, and so what's great about it is that I can always come back and run this again once I've changed something, or I can come in here and edit it and change one thing and run it again. So it's really powerful to use templates. If you don't do it, you pretty quickly get bogged into the just, hey, did I change what I was supposed to change? And it's just too much work to keep track of it. Okay, so let's look at the 1960s settings to see what I put. Um, this point zero .05 is from the there is a actually, let me see if I can find that really quickly. Yeah, so I found this document that's giving baseline metrics for these load requirements. Um, and so for an office, um, here are sort of contemporary levels. So this is what we'll use in the next round. But then what I did um, initially was, but this point zero .05 came from one of those standards. The metabolic rate I just left the same as in other. Actually, I think I looked that up, and that's the standard too. Um, but this equipment rate's very high. That's based on some kind of research, and this 2.25 is also very high for the lighting power density. This is assuming a lot of incandescent lights. It's interesting too if you read about luminance targets. They've changed a lot over time, and there's some things I've read that saying that basically it was lighting, or like people who could companies who could stand to stood to make money by selling more lights that set that kind of lobbied for higher luminance targets than maybe were necessary, or anyway, it's changed over time. Um, and this is sort of a standard setting. This is just a not a fancy hot water heater setup. Okay, so basically the idea is that everything's here is contemporary except for the lighting and equipment loads, which means the heating load on the building that they and I made it the people and all these were there all the time, and the equipment was on all the time. Um, I I don't think I've ever changed. I just set these at standards from the Department of Energy, or the 90.1 standards. Um, but I don't have any mechanical ventilation here. I did an envelope that's basically all concrete. So like the exterior wall is all concrete, which is what the Guggenheim would be, I'm pretty sure. Um, so there's really no insulation in this building, but there's no insulation in Ed Hall. And I don't think I'm not sure there's any insulation in um, the our building at Columbus Circle. So that's not an unrealistic setting. And then I just left these as the defaults, which I think are, I don't know, they're confusing to me. So I'm just not going to worry about that right now. Or by confusing, I mean they're not. These are not anywhere near what for example, the local law standard is prescribing. So I'm not sure where they came from. Okay, and so then we see by running, and also I did no windows. And so the idea here was that I wanted to. This is not a realistic building, obviously no windows, but I wanted to go through the process of just dealing with an envelope that's kind of pure, that doesn't have the effect of solar coming in, and it's also not dealing with the whole question of the really low R values of Windows. So because this is a learning tool, right? So what did we find? Um, Pretty high site EUI, and if I look now at my energy, so by the way, this is the energy use intensity per square foot. This is the total. Um, Really high loads here. Um, the zone temperature curves are interesting. The gray is the comfort zone. And actually, no, it's not. I'm not sure. I know the comfort zone doesn't go out to 80. Um, but anyway, let's just not even worry about that. This is talking about comfort, not energy, which is an important thing, which will be part of modeling, but maybe later down the road in the semester. Um, and then energy flows, where we see the actual effects from different components or different parts of the building. You can see that we don't have any windows, no orange. So what I decided to do first was to try to fix this um, lighting, which is the yellow, and the this mauve, or whatever that color is the equipment power density. So I think that's all I changed in the second. Yeah, I said loads, and also I said schedules. And so I'll show you what that does here. And so I'll show you what that means. I come into my library. I This is that template that I applied. Um, we now have the loads from member office. And by the way, these are the set points that I have, 75 and 70. And then the equipment power density. And do you understand power density? So watts per square foot, that's the amount of power um, that's being put out per square foot by the equipment. For lighting, it makes more sense. It's you think about it. I don't know what lighting one is here, but it's the amount of watts that you're putting out in terms of that are lighting the building per square foot. And so the more efficient so if you're using incandescents versus LEDs, the wattage is going to be much lower for the LEDs for the same amount of light. So that's going to show up here. So here's the 0.75 Um, the 200, that's how I got the 0.005 in the occupancy uh, rate. Let me go back to that. Yeah, so this is the 0.005 that I'm using everywhere, but here's that 0.75, and there was also 0.69 in the, so I very much lowered the equipment power density and the lighting power density, and I then scheduled um, these loads. So for example, and I just used schedules that were, these are from the DOE, so I think they come from 90.1, so these are all standards. I just typed in medium office, oops, and then you can find something that, see, so these, the 1A and all that, these are climate zones, so we're in 4A in New York City, and I found the one that was relevant, which was 4A building for medium office, and I did that for all of these. And again, if you look at them, we see that the power or the people are showing up. Which one is this? This is yeah, this is people. They're showing up at some of them are starting at 6, but they're all there at 8. They leave for lunch. So it's pretty detailed, and then they're slowly leaving over the afternoon. Let's look at the equipment. Equipment's more nuanced. It's well, that's just different. Um, there's a certain level of equipment on all the time, and then it ramps up when people get there. And the lighting, um, more complex also in terms of so these are um, set by standards that are based on research. Um, and I also scheduled the hot water. So the result then of that was, and it's the same envelope, uh, pretty drastic change from 248 to 148. So the point is right now that we're not changing this form at all. All we're doing is internal adjustments, and we can see that yeah, so and remember that these values change. So we're at like 609 for the lighting here in January. Um, yeah, first of all, it just went way down, and this is what I was saying before. The range of the y-axis changed drastically, so you just got to be conscious of this. But yeah, I totally wiped out the lighting and equipment loads, which was the goal. And then maybe it's helpful. I'll just keep doing this. So the next thing I decided to do was just to upgrade the heating and cooling system to so this is another template, but I could have also done this just by selecting those zones and changing the settings there. It just would not have been saved as a template. All I did here was adjust the. That's weird. I'm sorry. Sorry, I thought I'd pause, but I didn't. So there was some dead space in there. I was just checking. So this is not what this should be. So this is why this is important to keep track of these things. Like if I look at my spreadsheet, what is this? I look at my spreadsheet, pull it over. Um, we're in. I don't really need to do this because there's other ways to know this, but we were in this run. Let's see. Yeah, it's supposed to be the third run, and I'm supposed to have my COP at 3. Remember, COP is basically with 3. We're saying we're getting 3 units of heat for 1 unit of energy put in, or 3 units of cool if it's for cooling. So it's very efficient, but for some reason that's not showing up in my template. I'm pretty sure I ran it with that, so at some point I screwed that template up maybe. So let me go change it and rerun this just to make sure. So I'm here at heating and cooling, or maybe I didn't select the right one. Let's see. Uh, oh yeah, I just selected the wrong one. So I'm heating and cooling. The COP is 3. That's the only change I made. I know that because of my, um, I went through, and so I'm in C here, and there's nothing in the loads that were changed. I changed the COP to 3, and then nothing changed in the envelope for C. So I know that that's true. And then I ran this and um, got a massive change in site EUI. But look, watch the graph down here. I'm changing between the second run and the third run. Nothing changes at all. Why is that? What's different? So I had the exact same um, energy usage, or the profile is the same between these two runs, right? Um, but the energy use is drastically lower. Let's actually go to use intensity. So these are the same, right? Same, it's the same shape, but the energy usage is way different. 24 for this one, 9 for this one in January, kilobTUs per square foot. Um, so all we're saying is, so it's the same amount of heat that we require. It's just that we need to use less energy to produce it. Same amount of cooling down here that we need. So it's the same amount of heat when the red, same amount of cooling. It's just we have a more efficient way of producing it. So we didn't change anything about anything in the building that we know of. The systems are going to be different, so it might mean that we have to have a different floor to ceiling height. We have to understand what the systems mean. But at this level right now, all we're doing is saying we are making our mechanical system uh, more to contemporary standards, and that drastically increased the energy efficiency of the building. Why would we do that as engineers? Well, I mean, as architects, well, if we understand this a little bit, and then we're meeting with an engineer at a schematic design level, and we say, we're assuming that this, here's our design at this level. We think it meets the standards that we've set in our program, but it's making these assumptions about the about the mechanical system. So, hey, let's talk about that. And they might go, yeah, that'll work. Or they'll say, oh my God, that's going to cost you 5 times as much, or that's not practical. I don't know where you got that setting, right? But if you start the conversation, then you're sort of in control of it, or at least you're fixing the problem early rather than then coming in and having to make changes. It's called optimization, which usually means screwing things up from the architectural standpoint. Okay, anyway, so that was C. D, now okay, we've got a building. It's solid concrete. There's no windows. It's pretty energy efficient compared to our baseline. We have a 1960s envelope, but we're saving 31% on the baseline 90 EUI. But you can't live in it. There's no air moving through it. So we have to get real here and add some ventilation. So I did that. Um, and let me show you where I did that. I made a template, but it's just changing a couple of settings. So let's see what they were, just so uh, all I did was I turned on mechanical ventilation and left it at the contemporary, the preset rates for the template I base this on. So we are here. I turned on mechanical ventilation. So let's talk about this for a second. So we have uh, So there's two ways you can talk about how much fresh air you're bringing in. It can be how much you need per person, because that can be a code mandated amount. So we're saying it's 21 CFM per person. CFM is cubic feet per minute. So that's 21 cubic feet per minute of air per person in the building, or it's 0.19, let's just say 0.2 CFM per square foot. So I just turned that on, left those presets, and I have it on all the time. So it's not going to be that efficient. And the result was um, a pretty substantial increase in our EUI, and that makes sense. Now we're bringing in fresh air from outside, so it's 32 degrees outside, 68 degrees inside. We're just bringing in fresh air. We're going to lose heat that way, and we're also going to lose cool if we've got it 68 inside and it's 95 outside. So that's not an efficient way of doing it, but definitely, I'm sure that the baseline building, well, it would have had windows and it probably had a ventilation system, but it would not have had anything efficient. So this is realistic in some ways, though we still don't have windows. So the next thing I did was to make that ventilation system efficient to contemporary standards, and I did that by adding energy recovery ventilation. So let me show you that. And I changed a couple other things. Um, so the energy recovery ventilation template changed. Um, so now that the 21 was crazy high, and but I think that would have been probably typical of the time period. But that was I'm not sure where the 21 came from, but it was in another one of these presets. I think it was just in the Medium Office template that they use. So I use a standard from um, this sheet this is from the DOE, and these are supposed to be baseline. This is the average of buildings from of this type. Um, by the way, and these are the schedules that we changed were based on these. This is the hours per week, and then I figured out what that would be, and I made schedules. Oh, actually, no, the schedules that were in there for the under the DOE match those. I checked it. But here's infiltration rates, or I'm sorry, fresh air rates for office, 0.06 CFM per square foot, or 5 um, CFM per person. So that is what I used. Um, and so I updated to a standard level the amount of fresh air we're bringing in. Then I scheduled it, and I did that using a standard schedule. Let's see what it actually is. Um, it's this Medium Office 4A from the DOE Commercial Library. Um, and and then I chose energy recovery ventilation. Now I won't get into detail here. We need to understand these things. This is something I covered in 325. Um, that's the environmental systems too, but it's probably not something that everybody knows yet. Um, basically, there's two approaches. So basically, all we're saying is that we're bringing in fresh air, and there's a technology that's pretty straightforward by which we can. So we're exhausting stale indoor air, and we're bringing in fresh air. The stale indoor air, though, has the temperature that we want. What we're bringing in probably doesn't. And so there's a way of transferring heat energy and also, so heat energy is called sensible. So that's what uh, this setting would be. So there's a technology called an HRV that does that. There's something called an ERV, an energy recovery ventilator, that also recovers latent energy, which is from water in the air. Let's not talk about it right now if that's confusing, but it's just a different technology. I set it ours for that because in our climate that's good, or that would be the kind we would use. And I set a sort of standard efficiency. So in other words, we're saying that with that latent system that we're using, we're we are transferring 65% of the heat energy that's in the air um, to the incoming air. So we could actually go higher than that. This is a fairly standard amount. I did not turn on an economizer. Economizer is an awesome thing. All it's saying is that when the outdoor air, it's just a scheduling setting. When the outdoor air is at a temperature where you don't need heat recovery, then the heat recovery is turned off, and you're just bringing in it. So if it's 68 degrees outside, but you still need to have fresh air, then you can just turn off your ERV and get fresh air at the temperature you want it. I didn't turn it on because I think the scheduling, if it's conflicting with other scheduling, could cause problems. So I decided just not to do that. Um, okay, so all we did there was we implemented an efficient ventilation system, um, and so by the way, maybe you're going like this isn't architecture. This is just a bunch of engineering stuff we're doing. Remember, these are all once we understand this, which you need to know, if you don't know these things when you're modeling, especially a larger, no, actually, if you're modeling anything, you're just pushing buttons and you may have changed a setting or you may have a ridiculous setting in there that totally throws it off. So we need to understand the basics. Once we understand those, we can just apply templates that are the preset. Um, so it's not like we're going to spend a ton of time on this once we understand the basics. So when I changed to an efficient system, I'm back now basically to where I was without ventilation, which is incredible. Basically, I'm saying with ventilation, I added 15 kilobTUs per square foot to my site EUI, and now I'm back down to 62, which means I basically, it's a wash having that ventilation system in terms of energy, and now I have the ventilation, so that's awesome. Um, okay, what did I do next? Well, then I said, okay, I've kind of messed around with the 1960s thing enough. I've basically kept the envelope of a 60s building, but I've upgraded the mechanical systems and the loads to modern or to contemporary standards in terms of the equipment we have. So the next thing I did was said, okay, I'm going to go and now I'm going to do just a baseline building from the DOE standards. That's the middle of the road. Um, Actually, it's not the middle of the road. This is um, a building that's already been optimized in its uh, so this baseline EUI, the 90, is just like, okay, but whatever's out there right now in the existing stock, buildings like the Guggenheim, buildings that were built in the 80s, everything out there. Um, and then if we do the baseline fixes that or contemporary upgrades to our approach, this is the system we'd be using. And now we've made a huge jump from 62 to 25. We're well below the baseline. We're saving a lot of energy based on that, and we're maybe getting, now we can start looking at carbon, though that number is wrong, and start looking at local law 97. But I'm not going to worry about that right now. I'm just going to try to see what's a realistic number, because right now we still have no windows, right? But so what were the settings that I changed for that? We are now in, let's see, we're in E. Uh, yeah, so no, we're in F. So all I changed here was the envelope and the um, air infiltration. So I'm sorry, the these numbers are wrong, by the way. I was actually going to delete these. Let me talk about that for a second. There's two ways that you can measure air infiltration. Did we even talk about it? I did briefly. I know there's just so much going on here. Um, but again, I'm just trying to give you guys some sort of beginning. Or maybe you already know all this stuff. I don't know. Um, ACH is air changes per hour. So that's how many times the full volume of the air is exchanged through leaks in the building per hour. CFM per square foot is how much per cubic feet per minute of air is being exchanged per square foot of exterior facade. So there are just two different ways of measuring it. There's reasons to use one over the other, but I'm just going to use ACH for this. And so I went from 2, which is a super leaky, well, pretty leaky older building, to point 0.2, which is a pretty good contemporary building. I mean, you can get better than that, but that's no slouch. Um, and so those two things together are what brought us way down here. And so let's just, and we can see that. Actually, let's go look at the template. Um, so the baseline and 90.1 is the standard that I talked about, the 90.1 standard. The main things we did is we upgraded. So now we've got a R value of 31 in the roof, which is not extensive, but that's way better than we had no insulation at all. Only an R value of 10 in the walls, but that's with a mass wall is not terrible because also there's less thermal bridging and stuff. It's got thermal capacity. Um, so that's the standard for a decent building these days. The same thing with these others. So these were updated. Um, to a contemporary standard, and or like a high performance contemporary standard, and or not super high performance, but a decent standard, and then a really good air tightness. And that's how we got this result. And then I started adding glass. And I'm just going to click through these, and I can share this model with you guys if you want to see it and mess with it. You just let me know. So the next thing I did was I did the 90.1 baseline, and I added windows. And you see that, and I just used the default glazing, so that's single pane glass, considerable change. And the windows I added were was a curtain wall. Let me just turn these off. So I did a curtain wall around the entire building. I think it's like 75% because if there's so it's a somewhat realistic. There's a floor plate and room for mechanicals there, and then there's a slab area down here. Um, so it's a curtain wall with required spandrel opaque envelope. Um, and So we got a pretty considerable drop in our efficiency by adding the glass, which makes sense. Um, I went back and looked at the curtain. I added that same glass to our original 1960s envelope just to see the difference, and you'll see that if you measure, so this is 248 to 259, it's still about the same number of EUI, but it's in terms of the percentage, it's really not very much. So it kind of makes sense that back in the day when you just had a concrete building, you could, with no insulation, you could throw a single pane current wall on it, and it made a difference. But when we haven't talked about, well, it made a difference, but didn't make a huge difference. Whereas now it's a substantial amount. We're talking between 25 and 35, so that's 30% or something change. Um, and so then I started. What did I do? Oh, this is with. Then I did. I started upgrading the glass. So let me see if I did. So this was the 1960s with old glass. This is with new glass. Then I did the 90.1 envelope with the glass that they would specify. And there now we're still over. We've lost like 4 EUI, 4 kilobTUs per square foot, which is um, nothing to sneeze at. But we haven't optimized anything. Um, So anyway, the point being that you can go in and without changing anything with our volumes, without doing anything with the spatial relationships, we're just trying to optimize based on a given, see how close what we can do with a fully designed envelope with glass, maybe some shading. Can we get to a decent level of energy use, and then move? And if we can, then we can move from there and start looking at daylighting, etc. Of course, we wouldn't design a building this dull, probably, or this boring, especially in school. But this is an exercise, right? To try to understand. Just make sure you get it. Let's go look at. I'm going to edit. Oh, by the way, if I'm going to edit, let's say I want to edit my glazing, all of my glazing at once. If I select all of my zones, and I think one glazing has to be, you have to have one of these facades open so you can see a glass in there. And I edit. So by the way, you can select zones by holding Shift, and then if you edit, you're editing all of them. And so let's say I'm like, I don't want to edit the zone, but I want to edit the glass. If I get out of the zone, then the glass comes up, and now I can edit I can change it for all the glass. Um, and remember, then we have access to all these different glazing packages, and that's all I'm changing from here on for a while. So the next thing I did was, no, and that's all, so I've got my curtain wall with default glass in a 90.1 envelope, so a contemporary envelope, and then I've got it with, so default glass is single glazing. Then I did it with the standard glass that they suggest in the standard. And then I did it with some high performance glass, which didn't really change it very much. So, you know, even right there, you might go, yeah, I realize this is triple pane glass. You know, you really have to have a complete system together where you're tuning everything to make that kind of level of glazing useful. The point why am I bringing that up is that even at this level, we can learn things and have and start thinking about things like cost and other really practical factors just with a model at this level. Okay, now the next thing I did was just add some shading to try to mess with that. So I did all these different shading patterns um, over the same glazing. I started, by the way, with this ridiculous shading that's not possible, but I knew that if I wanted to shade the east and west glass, and that's if I go and look at um, energy flows, I can see I have a lot for this. So here I'm with the high performance glass with my curtain wall on my 90.1 envelope, and I've got a lot more um, gains in the summer. I like these gains in the winter, and I might even want more than that, but I've got too much in the summer. If I then put in this crazy shading, so I'm saying, okay, I'm just going to take a swipe at this in an absurd way to see if I can get it to go down. By the way, I don't think I mentioned this. This gray stuff down here, this is what you're actually having to produce. So I probably haven't even talked about this. I'm sorry. So this black line is 0. Everything above it are gains. Everything below it are losses. So if we have a window that is balancing losses and gains in the winter, then it's a good window, right? And we can dial into this for individual windows more in different. This is not talking about that right now, but so this is a place that we can study glass in some detail. Anyway, so I then tried this shading I wanted to see if I could reduce these gains in the summer when I want to have cooling. And with that crazy amount of shading, was able to do it somewhat. And what did that do to my EUI? Dropped it down. At this point we're pretty low, so it's hard to get huge gains. Um, but it went in the direction that I wanted it to go in, so that's cool. And so I said, well, can I now actually do this in a realistic way? So I did a different shading pattern, which was so again, this is sort of a technique where I do something that's not realistic, but to see if I can get an effect that I want, and then I go try to emulate it in a real way. So next thing I did was I just added this glazing or this shading. Let me turn off the glass because it just makes it confusing, I think. And so that it resulted in an improvement um, over the no shading, um, right? But it's not as good as, so this is the one I'm just doing that we're seeing expressed here graphically. It's better than no shading, but it's not as good as the crazy, ridiculous conceptual shading, which is this. Sometimes it starts slowing down when I have these many models. If I close this and open it up again, it'll speed up again. So that's just something to realize. And then I just started playing with this in different ways. So the next one I did was I changed the glazing. I then added an egg crate. So I added um, this pattern. That didn't really have a huge effect. Let's see. Dropped it down a little bit. So this would be that's a lot of work to put in all that glaze, all this, or not work. Maybe it's something you want architecturally, but I'm saying there's not a big difference between the single and the double. I mean, between um, this and this. I found in this analysis. Then I added it on the south. I'm not going to go through all these. I'm just saying that I tried a bunch of different shading. Um, And so I'm still doing pretty well. This is a respectable EUI for trying to be really high performance in the context of designing in New York City right now. How do I know that? I'll show you in a minute how I know that. But then I said, well, another way to prevent heat gain on that glass is to get rid of some of the glass. So I took out the glazing on the east and west side. So right now I've got glazing all the way around. I think I've got, let me just turn off the shading. So then I said, okay, what if I just get rid of this glazing on the east and west, have north and south, um, and then without any shading at all, I'm down to where I was before too. So I can shade glass. I can adjust the amount of glass. Now I think this is about at 40% glazing. That's window to wall ratio. 40% is the maximum in code actually. So whenever you have a curtain wall that has more than that, you have to do an energy model to establish that it meets code in a prescriptive way, not a performance. I mean, from a performance standpoint, not a prescriptive standpoint. Something else I can talk to you about if you want. Um, then I took it one step further. I went to a passive house level, and so I developed a passive house envelope and modeled it with passive house levels of air filtration, which are lower. And so now I'm really getting down. That was a big jump, but it may not. A lot of people aren't going to want to do that there might be cost. That's where you really have to start talking about. You really dial in and make sure that you understand how much it's going to cost and whether it's practical. Um, it's totally doable at cost actually, but not everybody has the skills for that. And then I started playing with the glass, trying to get it further down. And then I did, um, finally, I played with the natural ventilation. And with natural ventilation, I was able to get it down even further. I'm going to talk about that in a different video and not now. I think we've got plenty for initial stuff. I think I've kind of inundated you. Um, but I'm going to show you one more thing, but I'm going to do that in a second video. I mean, in a final video. So the point is here, I've gone through the outputs of these different, by changing different inputs, the outputs I got, they were tuned for specific reasons. I've gotten now, this is and I think that I've got, let's see, I can't remember what shading pattern I actually used for the final version of this. I think it was, it might have been, um, that, or it might have been, probably this. Nope. I think that's the shading in this design. So, and we don't actually need it on the east and west because there's no glazing there, but maybe there'd be some other reason for it. So maybe it's more like this. But anyway, there's some kind of shading implemented. And so we'd have some idea of our architectural approach this is you see buildings like this. This is not just a conceptual model. Um, okay, so, and we started here at 248 EUI, and we got down to 15 using the same form, just with changing all the variables that we've gone through. So let's see if this seems like a realistic amount of EUI in New York City based on local 97. That's in the next video.